Myself, I am Dr. Jntuh. In this class, I am going to discuss with the various page replacement algorithms. Before moving to the topic, so the first replacement algorithm which we are going to discuss is least recently used algorithm, that we can replace a page that has not been used for the long period of time. So this is the concept behind the particular algorithm. So these are the given reference string. Here we are going to consider the three frames 701. So after that 203, 042, 303, 212, 017, after that 011. Okay. So this is a given reference string here. First, so this three procedure is common to all algorithm. So first inserting bit is 7. So after that we are going to insert 0, 7, 0, 1, 7, 0, 1. Okay. So now we are going to see the three elements, that is 701. Next we are going to insert the element, that is 2. So out of these three elements, so 7 is the least recently used and it is lastly used. So that we are going to consider. So by eliminating the 7, we are replacing the 7 with 2. So now we get 2, 0, 1. So the next element which we are going to insert is 0, which is already present in the last string. So we need not to insert it. So we put as hit sequence here. So moving to the next one, we are having 201 here. So now we have to insert 3. Okay. So now we have to consider this 0, 1 and 2. Out of these three elements, so 1, 2 and 0, out of these three elements, 1 is the last frequently used because we have to take the three elements now. So 1 is the element which we are going to replace with this. So eliminating the 1, we are having the 3. Okay, now we have a new string that is called as 203. So next element which we are going to insert is 0. So already the 203 is present, 0 is there. So we put the same sequence here and put the sequences hit. So after that we are going to insert the value that is called as a 4. 4 is going to be inserted. So now we are going to consider the value between the 203. So now 203 with this 203, 2 is the last recently used algorithm, the variable. So we are replacing the 2 here. So instead of 2, we put 4 here. Now 403. So next element we are going to insert is 2, which is not here. So we have to look this 4, 0 and 3. So out of this 3 has been lastly used. So we are eliminating the 3 and put 2 here. Now we have 402. So now in the 4, 0 and 2, out of this 0 is the last used. So we are eliminating the 0 and put 3 here for next element. So now we are having 4, 3, 2. So next the inserting element is 0. So now compared to the 4, 2, 3, comparing these three elements, 4 is the last element which we are used. So instead of 4, we are put 0 here. After that 3 and 2, 0, 3, 2. Okay, now we are going to insert the element that is called as 3 here, which is already in the last string. So we need not to put the sequence. So we can put it as a hit sequence. So next element is also 2, which is also there in the string. So we need not to put that particular element. So next element is 1. So we need to insert here. So considering these three elements, that is 0, 3 and 2, last used element is 0. So we replace the 0 with 1. Now we have 1, 3, 2. So next element which we have inserted is 2. So which is already present in the given string. So we need not to insert it. We put this sequence as a hit sequence. So the next element which we have to insert is 0. So now we are inserting this 0. So now we have to take 1, 3, 2 string. 1, 2, 3 string. So now the 3 is the last frequently used. So we replace the 3 with 0. Now we have 1, 0, 2. So next element is 1, which is already in the string. So we just enter the sequence and put it as a hit. So next the element which we are going to insert is 7. Now we are going to consider these three elements, that is 1, 0 and 2. 1, 0 and 2, out of which 2 is the last recently used sequence. So we are replacing the 2 with 7. So now we get 107. Out of this 107, 0 is the element which is last string that is the element that is present in the last string. So we need not to apply anywhere. So just we write the sequence and put it as a hit. Likewise, 1 is also present here. So we put it the sequence as 7. Okay. So now we have to calculate the hit sequence 1, 2, 3, 4, 5, 6, 7, and 8. 8 hit sequence are there, and the fault rate is 12. Okay. So which we put here. Okay. So what are the advantages of least recently used algorithm? It is very most efficient. It is not a procedure algorithm. Here we can solve the algorithm very efficient and performance manner. So the disadvantage of this is it requires more hardware support. It is highly expensive. So next algorithm is Lre algorithm by using the implementation procedure. Here there are two types of implementation is there. One is a counter implementation, another one is a stack implementation. Each page table entry has a fixed amount of time added to the CPU register, that is called as a counter implementation sequence. Whenever a reference is given to a particular page, the content of the particular clock is going to be copied and the smallest amount of time is used. So this is called as a counter implementation. Stack implementation is nothing but which we are moving the recently used pages to the top of the stack. So here the entries must be removed, and from the middle of the stack it is used to accommodate with the doubly number of elements. So hence this stack implementation has been removed the element from the each time from the top of a stack. Okay. So we can say the example. For example, here we are using the stack form of variable. So before inserting the element, we should remove the element each time from the top of a stack. For example, 2, 1, 0, 7, 4 are there. If we want to remove the particular element, we have to remove the element 2 and we have to insert the another sequence. Like this, we have to consider this. So first we have to replace the 2 with another number. After that we have to replace 1. After that we have to replace 0. After that we have to replace 7. And after that we have to replace the 4. Like that, similarly we can fill this form and use by using the single number of string. Whenever we are going to string the particular, eliminating the particular element, we have to put that element also and which element we are going to replace. So that also we have to enter at the each time. So this is called as a removing the element from the top of a stack. So here the reference bit are there. So reference bit is nothing but each page will be having initializing value, that is called as a reference bit. Either it can be 0 or it can be referenced as 1. So there may be another second chance replacement algorithm, that is nothing but if the particular process is not performed in that stack queue, it can be replaced with the circular queue algorithm, where last in first out algorithm has been used. There first in first out has been used in the stack concept. Here last in first out has been used. So this is a diagram for the second chance page replacement algorithm. For example, so this is a queue. Whichever the member which are standing at the last will be moving out of the sequence, that is last in first out. Okay. So this algorithm is called the second chance algorithm. Moving to the next one, enhanced second chance algorithm. So which is nothing but we are going to modify the reference bit in terms of a pair. We are going to modify both the numbers with the reference as well as modifying capacity of that particular sequence. Here the called off sequence and the empty classes are arranged. The circular queue can be performed by using this more number of times. For example, we can say that least frequency algorithm and most frequently algorithm are the best example for this sequence. So this is an example for the last frequently used algorithm. Okay. So consider this is a string. So now we are having the frames here. 3 number of frames we are going to consider 701, 203 and 304, 423, 032, 120, 170, Like that, we have to consider the 3 number of frames here. So first we insert 7 here, after that 0 here, so it becomes 70. After that 1 here, 701. After that we are going to insert the 2 here. Okay, here we are going to calculate the frequency of the frame also. For example, here 7 has come 1 time, so we put 1 here. 0 has come 1 time, hence we put 1 here. 1 has come 1 time. So this is for the initially frequencies. Okay, so after that each time the frequency will be changing. We have to calculate it each time. Okay, so now we are going to use the least frequency used. Okay, coming to this sum, out of 701, least frequency use is the last algorithm. So we replace the 7 by 2 here, hence it become 201. So after that 0 is here, 0 is already present in this string. So we simply put 201 and put it as a hit sequence here. So next we are going to insert the 3 element. So now we have to consider the 201. Okay, out of which 1 is the least frequently used algorithm. So we are going to replace the 1 with 3 here. So it becomes 203. Okay, so now the next number which we are going to insert is 0, which is already present in the string. So we put as it is 203. It is a hit sequence. After that, we are going to insert the number 4, which is not there. So now we are going to consider the 203. 203. Out of this, least frequently used is 2. So we are eliminating 2 and put 4 here. 403 has been arrived. So next inserting element is 2. Out of 403, the least frequently used is 3. So we replace 3 out of 2. Now we are having 402. So here, the next element which we are going to insert is 3. 402. Okay, out of which 0 has been 402. So out of which the 4 has been going to be replaced with the 3. So now we get 302. So this is a new string which we got. Next element to insert it is 0. So which is already present in the previous string. So we put as it is a string here and put it as a hit sequence. After that 302, it is a hit sequence. So 2 is also already present. Put it as a hit sequence. So next element which is going to be inserted is 1. So the 1 is the element which we are going to insert. Previously we are having 3, 0 and 2. 3, 0 and 2. Here we are having the least frequently used sequences 3 here. So we replace the 3 with the 1. Now we are having 102. So next one is we are going to insert 2 here. So 2 is already present in the string. So we need not to replace a particular one. So just we have moved the particular sequence and put it as a hit. 2 is also there. We put it as a hit sequence. 1 is also there. Okay, now considering the 102. So the last least frequently used 102, the string is 1 is there. So we put replace the 1 and put 7 here. Now it becomes 702. So next sequence is 0. 7 is 0 is already there. So we put same string as 702. And it is a hit sequence. So the next element which we are going to insert is 1. So now considering this 7, 0 and 2. So the last frequently used particular string is 7. So we put 1 here. Okay. So likewise, how many number of 2s are there in frequencies means 1. 0 is 2, 1 is 1, 3 is 1, 0 is 3. 3 times we have used during this entire process. 4 is 1, 2 is 1, 3 is 1, 0 is 4, again 3 is 2 and 2 is 2. So like that we have to calculate the frequencies of the each and every string at the allocation of an algorithm. Okay, so this is called as least frequently used algorithm. So this is an equal allocation algorithm. So for example, each and every time we are going to free frame that buffer. Okay, so moving to the next one, frame allocation. It is an algorithm that is used in the multiprocessor, which is used to decide how many minimum number of frames that are going to be takes part in this function. Okay, now we are going to consider the 3 leftover frames that is called as a free frame buffer pool. So this equation is otherwise called as equal allocation. So disadvantage of this is depending upon the varying size of a process, we cannot sense that the equal number of process. So the proportional allocation method and the formula for this is A of I is equal to S of I divided by capital S pointer M. Okay, variance is the sum of sizes of all processes and M is the number of frames in the system which we allocate, and PI represents the process and SI represents the size of a particular process which we can dynamically allocate the system. So considering this is a question, in a system 62 frames are there, process is 10 kb and another process is 127 kb, then we will calculate the first process by using that same formula, that is the formula has been used here, that is AI is equal to SI divided by S star M. Like this, we can calculate the how many number of frames that has been takes part in this function. So the advantage of this particular process, we can equally share the available frames depending upon the needs. The disadvantage is highest priority will be treated and lowest priority will be considered at the end of a frame. So another important feature of our frame allocation is a global replacement allocation algorithm, which is nothing but we are going to select the set of frames which are currently running, which are not running. Like that, we are going to select out of which the lower priority will not be given, higher priority sequence will be given. So the advantage of this process is higher priority process will increase the frame allocation strategy compared to the low priority process. The disadvantage is we cannot every time we cannot handle the own page fault rate. The set of pages used here is the one of the processes. Depending upon this, the paging behavior will be happen. Local replacement algorithm is another technique in which each process will select only its own set of allocated frames. The advantage of this particular process is the pages will be allocated to the memory in the very refined process, and the page fault ratio will not be affect the other page. The disadvantage is lower priority process will not be handled as much higher. The higher priority process will be handled and the fault ratio will also be more in this process. Thank you.